Welcome to G Fun Facts Online, where we unravel the amazing science shaping our future. Today, we're diving into a world so small, it's almost invisible, yet so powerful, it could redefine technology as we know it. Imagine printing complex, three-dimensional objects, not with plastic or metal, but with materials that conduct electricity with zero resistance, superconductors. And not just any objects, but structures tinier than a human hair. This isn't science fiction. It's the cutting edge of Nano-3D printing for superconducting materials, and it's happening right now. So what's the big deal? Superconductors are incredible. They can carry electricity perfectly without losing any energy as heat. Now picture being able to print them into tiny, intricate 3D shapes. We're talking about building the components for next-generation quantum computers, ultra-sensitive sensors that can detect the faintest signals, and super-efficient electronics that could slash our energy consumption. This technology allows us to create superconducting nanostructures with custom-designed features, opening doors that were firmly shut with older manufacturing methods. How on earth do scientists print something so small and so super? It's not your average desktop 3D printer, that's for sure. One of the star techniques is called focused electron or ion beam induced deposition. Let's call it FEBID or FIBID for short. Imagine an incredibly fine beam, like a microscopic spray painter, drawing 3D structures atom by atom from a special gas. Using a helium ion beam, for instance, researchers have crafted tiny superconducting springs, or nanohelices, from materials like tungsten carbide, with diameters as small as 30 nanometers. That's thousands of times thinner than a human hair. These tiny springs even work, becoming superconducting at very low temperatures. Other cool methods include two-photon polymerization, which creates tiny plastic templates that can then be turned into superconductors. There are also laser-based methods that use ultrafast lasers to sculpt metal structures, and even something called ice-assisted electron beam lithography, which uses, you guessed it, ice instead of traditional materials, speeding things up. And for those who like something a bit more familiar, there's direct ink writing. This is closer to traditional 3D printing, where special inks containing superconducting precursor powders are extruded layer by layer. After printing, these parts are heated up to create the final superconducting material. What kind of supermaterials are we printing? Scientists are experimenting with a whole range. Tungsten-based materials are popular for those beam-induced methods we talked about. Niobium is another classic, and researchers have made niobium carbide nanowires that superconduct at relatively higher temperatures. But perhaps one of the most exciting is yttrium barium copper oxide, or YBCO. YBCO is a high-temperature superconductor, meaning it doesn't need to be quite as frigidly cold to work. Recently, scientists figured out how to 3D print YBCO and then treat it with heat to create a single crystal structure. Why is that cool? Because single crystal YBCO can carry way more current than its less organized counterparts, all while being shaped into complex designs thanks to 3D printing. Okay, tiny superconducting spirals and custom-printed YBCO are neat, but what can we do with them? This is where it gets really exciting. First up, quantum technologies. We're talking about building the tiny, complex circuits and connections, the qubits, needed for powerful quantum computers. Imagine nano-sized S-qubits, or superconducting quantum interference devices, that can detect incredibly weak magnetic fields. These could be used for anything from medical imaging to mapping brain activity. We could also see better single-photon detectors, crucial for quantum communication. Then there are advanced sensors. Think about sensors for magnetic or electric fields that are shaped in unique 3D ways. These complex geometries aren't just for show. They can give the sensors brand new capabilities. We could also build better bolometers, devices that detect faint radiation like microwaves. And in electronics and spintronics, we could see the rise of fluxonic devices that control tiny magnetic fields, and components for electronics that are not only powerful, but also incredibly energy efficient. Imagine reconfigurable devices that can change their superconducting properties on demand. The possibilities even stretch to medical applications like improved MRI components and even high-field magnets for particle accelerators. So what makes Nano-3D printing the superstar for superconductors? First, miniaturization. We can make devices smaller and more compact than ever before. Second, complex geometries. Think helices, bridges, tiny lattices, shapes impossible with old-school 2D methods. These weird and wonderful shapes can unlock new physical properties. Third, material customization. Scientists get precise control over what the superconductor is made of and how it's structured at the nanoscale. Fourth, enhanced performance. By tailoring the 3D design, we can boost things like how much current a superconductor can carry or how strong a magnetic field it can withstand. Remember that single crystal YBCO? That's a perfect example. And finally, integration. This tech makes it easier to combine superconductors with other materials and technologies, building even more sophisticated devices. Now it's not all a walk in the park. This field is cutting edge, and that means there are challenges. Scientists are constantly working to get even higher printing resolution and to control any tiny defects that might form. Making sure the printed materials are super pure is also critical for them to work perfectly. And of course, figuring out how to make these amazing nanostructures on a large scale and affordably is a big hurdle. There's also still a lot to learn about how superconductivity behaves in these complex 3D nanoshapes. The physics can get pretty wild, but the future is incredibly bright. Researchers are exploring new materials, refining printing techniques to be faster and more precise, and even using artificial intelligence to help design these nano superconductors. The ability to precisely control superconductivity in 3 dimensions at the nanoscale is a massive leap forward. It's truly paving the way for transformative technologies that could change our world. And that's a glimpse into the mind-bending world of Nano-3D printing for superconductors. From quantum computers to life-saving medical devices, the potential is truly staggering. What tiny wonders will they print next? Thanks for tuning in to G Fun Facts Online. We hope you found this journey to the nanoscale as exciting as we did. Join us next time for more amazing facts from the frontiers of science. Don't forget to subscribe.